We're going on now to Chapter 5, Section 1 of Finite Math, Math 1127, where we're going to deal with linear inequalities. Now, in an earlier section, we did do what are called linear equations. Now, something is linear if the exponents on the variable are only to the first degree. And if they are, we don't write them. So to make these equations into inequalities, what we need to do is to change the signs from an equal sign to an inequality sign. So we can do that just by making this greater or equal to this, and we can make this one less than or equal to that. So we've changed them from equations to inequalities. And the difference between them is that along the lines there are a series of ordered pairs that are the answers. They're found along the lines of the graph. In fact, let's just graph this one to see what we're talking about. Now, if this were the equal sign that we originally had, we would graph this by plotting the y-intercept, which is -3, putting a dot there. We then look at the slope, which is this, 2 over 1, and we would go over 1, and then up 2, and then this would be our line. Hopefully you go through the points too. Now, all of these ordered pairs along this line are a solution for this original equation. But now it's an inequality. We're saying that y is greater than or equal to this. Well, in this case, and we're thinking of the word boundary lines, if it's equal to something as well as greater or less, in our graph we use a solid line. If we find, let me just write it here, so greater than or equal to, less than or equal to, you're going to use a solid line. And in a math lab you have that choice. Here this is either going to be greater than by itself or less than. So that's our boundary line. And in this case it was greater than or equal to, so it's a solid line. But there's also another area in which there's lots of solutions. We call this the solution region, and we indicate it on this work in this section by shading the sections that are applicable. So here we want to find out, where is y greater? Well, if you have a positive y, the region that is greater, again, this is one of my little definitions, is above the line. So this is your solution region. So not only are items along the line included in the set, but also in this shaded region. And this creates what is called a half plane. This is the half plane of the solution. This is the other half plane where there are no solutions. Now, another word we might add here is a trial point. And a trial point is a point in where you would try to see, is that the correct area of shading? One of the favorite trial points is the origin, 0, 0. So what we do in there is we put y is going to be 0, and we have here 0, and then this x is a 0, so this becomes 0. 0 is greater than -3. If we put this ordered pair into this inequality, is this a correct statement? Is 0 greater than or equal to -3? And the answer is yes, it is true. So the point being there, that is the area of shading, and that's where we put it. Now, if we ended up that by putting this point there, it wasn't true, then the shading would be on the other side. And you could have used a trial point from the other side as well. Okay, in this next little example, we made it an inequality by putting the inequality sign there. And a technique for solving it, when it's in this form, is to use this special T-chart. This T-chart is called an X and Y intercept T-chart. By making a T-chart, putting an X and a Y, a 0 there, a 0 there, and then putting this 0 in this first equation here. Well, if X is a 0, Y, as you divide both sides by a -3, is a -5/3. And if Y is a 0, this is going to be a +5/2. And you might say, well, how would I graph that? Well, again, you can use that basic technique. There's a graph. And I would make wide spaces here. So if X is 0, that would be there. Y is a -5/3. So a -6/3, that would be a -2. So 5/3 is right about there, maybe up a little higher. And then here we have X is a 5/2. That's like 2.5. So that would be right there. And then we would make our line. And that would be our boundary line. And since it also included the equal sign, we use the solid line there. But now we have to figure out, where do we shade? What is our solution region? So we're going to use a trial point. And I like the idea of 0, 0, which is right there. And if we say that X is 0, so that becomes a 0. Y is a 0, that becomes a 0. We have 0 is less than or equal to 5. Is that a true statement? Is 0 less than or equal to 5? And the answer is yes. So your solution region then is above the line in this case. And you can also see it here, if a negative y is less than a positive y, you may recall that eventually when we have to divide by a negative, we have to reverse the direction of that inequality. So a negative y is less, a positive y is going to be greater. That's why we shade above. Or you use the trial. Okay, we're going on to some examples now from section 5.1. Wants us to graph this. So I guess I left out the inequality sign on that. Yes. Actually, it starts us off by saying, think of it as an equation. So let's graph the equation. And since it's in standard form, we're going to use that special t-chart. So if x is a 0, we get y is going to be a -2. If y is a 0, x is going to be a 3. So this one works out a lot neater. So 0, -2, that's our y-intercept. A dot right there. And then 3, 0. 3, 0 right there. And again, since it includes an equal sign, for our boundary line, we're going to use a solid line. And it goes sort of like that. There you go. Now that would be the equation, but this is an inequality. But if you remember, we said a negative y is less than, so a positive y is going to be, we had to reverse the sign, greater than, so we're going to shade above. And the test point, once again, would have been 0, 0. And if this is 0 and if this is 0, is 0 less than or equal to 6? Yes, that's true. This point is in the solution region. So remember, all the points along the line are solutions, and then anything in the shaded area are solutions. There's an infinite number of ordered pairs. All right, going on to example 2. Here, this is a straight little equation. Y is greater than -3. Well, this equation, you might recall, is in the form y equals b. And b was the y-intercept. So here we have an equation that happens to be a horizontal line going through b, the y-intercept, which is a -3. So, since it's only an inequality, we're going to use a dotted line going through -3. Now, we have to shade. This one's pretty easy because it says y is greater. That's a positive y is greater. So we're just going to shade above. Now in this equation, again, it looks a little strange. There's no y, it's only an x. So we solve for the x by dividing both sides by 2. And we get x is greater or equal to, I can change it to 2.5, makes it a little easier to graph. And this special form of our linear equations is x equals a, where a, recall, is the x-intercept. So there's 1, there's 2, there's 3. So 2.5 is in the middle, and this is going to be a solid line going through there. But again, we have to shade. It says x is less than or equal to this. So where is x less? To the right of the line or to the left? Well, on this side, these get to be negative numbers, so it's to this side that we shade. And in this case, notice it's a little backwards. We could solve for y by dividing both sides by 3, and we could write it the way we're more accustomed to. That will be y, open end toward the y, is greater than or equal to 1/3 x. Here the 3's cancel out. Remember there's a 1 there. So this is sort of in slope-intercept. There is no b term, so b is 0. That indicates it's going to go through the origin. So as we graph this, our y-intercept is at the origin. Our slope is 1 over 3. So whatever technique you're used to, this is my run. The lower number is the run, x units. So 1, 2, 3. Our rise is 1. We're going to go up 1. And this is going to be a solid line. So looking a little bit like this. And we still have to determine where we're going to shade. Well, y is greater or equal, so it's a solid line, we're going to shade above. Now in this case, we couldn't use the origin as a trial point. Continuing with example 3, and one of the things I was looking at this word, it's trail, it's trial, so hopefully we have that straightened out. Find a linear inequality that goes through these 2 points, and this is the graph of it. Well, a couple of things are going on here, and again, depending how much background you have. In earlier math courses, you went through some of this. For instance, you had the slope formula. So if we put this data into this slope formula, we get 0. That would be our y sub 2 minus our y sub 1. And it would be our x sub 2 minus 0. So we end up with a negative 6/8, which is a negative 4, how about 3/4. So our slope is a negative 3/4. And we did have an equation, you might recall, y equals mx plus b. That's a given. And we now know the slope. Our slope is a negative 3/4. And our y-intercept is where this line is going to cross the y-axis. Well, it's when 0 is our x, our y value is 6. That's our y-intercept. Now we could have picked much of this information up from the graph. First of all, since it's starting high and going down, this is negative slope. And if we were to count the number of units here, there are 8. Number of units here, there are 6. And since it's negative slope, it's negative 6 over 8. I use these 2 points, but I could have picked it up from the graph as well. But I am aware of this formula. I put the slope in there. And this is my y-intercept. By the way, this is the x-intercept. The y-intercept, the standard form, is 0, b. B being your y-intercept, and this one is a comma 0, where a is your x value. But another thing they wanted on this was to have this slope-intercept form in standard form. Now, how do we put it in standard form? Well, one of the first things I would recommend, I think it's time to change color, is to multiply every term by the 4 to get rid of it. So this becomes a 4, and this will be a 24. So we now have 4y equals, these cancel out, a negative 3x plus 24. And now the only thing remaining, to put it in standard form, we have to take the x term, bring it over to the other side. So when it comes over as the opposite sign, 3x plus 4y equals 24. Okay? Now, keep in mind that this was an inequality, and we don't have the inequality side in there. So we want this to be less than or equal, because it's shaded under a positive y. Again, lots of stuff going on here, and depending where you are in your skill of this type of thing, you may have to repeat it or read the book. You'll have a chance to do some practice. All right, for the last example that they're giving us in the textbook on this section, they're talking about an application where there's a sale for a rock concert of tickets. And again, I've never been to one, so I can't tell you, wow, these prices are something. That if you are standing in the field of this stadium where this rock concert's going to be, to get to the field, it's $125 per ticket. If you get a seat in the stands, you can actually sit and have your eardrums destroyed. $175. So there's two types of tickets. And we're saying let X be the standing in the field tickets, Y seated in the stands ticket, and this band, they're a pretty high-powered group here, they want to earn, that is, have a gate of at least $700,000. Wow. Well, what they're wondering is how many types of tickets would they have to sell in order to meet this gate of this amount of money. Okay. Now they also give us some requirements that when we set up our graph, that y is greater or equal to 0 and x is greater or equal to 0. That means it's going to put us in the first quadrant of the graph. That's all that that means. So what equation could you set up? Well, we don't know how many X tickets, but if they sell at $125 each, that this will be the amount of money that's brought in from the sale of the standing in the field tickets. And 175 is seating in the stands. Oh, got that one wrong here. That should be a Y. Remember, if you see an error, get a bonus point. All right. So there's my basic inequality. Standing tickets, seating tickets, you want to make at least this amount of money. Now, those are pretty big numbers. So I can make these numbers smaller by dividing everything by 25, which is what I've done here. So when I cancel this, I end up with 5. When I cancel this, I end up with 7. And when I cancel this, I end up with 28,000. Now these numbers are a little easier to work with. Now, since this is in standard form, I'm going to use that special T-chart. that'll give me my y-intercept here and my x-intercept there. So I set up a little chart using my qualifiers. That's what these are. And I'm going to use a solid line. And I'm going to plot my first point, my y-intercept. When x is 0, my y is 4,000, right there. Now, when y is 0, my x-intercept is 5,600, which is between 5,000 and 6,000 right there. So any combinations along this line would be, any ordered pair would be the number of tickets that would need to be sold to meet this amount of money. And then any ordered pair out in this area means they've made over $700,000. Wow. Again, this is a little bit beyond my comprehension, but for fans, I'm assuming those are reasonable prices. And this will wrap up. You'll have some practice, some quiz bees, and then there's 5.2.